Hello everyone, welcome to Learn ReactJS for Frontend Development by CodeChef. As your React application grows, managing state and building complex user interfaces becomes trickier. Small updates or mistakes might lead to long code or unexpected bugs. In today's lesson, we will be looking at easy ways to handle states safely and how we can build UI that stays stable even after things get advanced. So let's begin. So let us look at how we can manage complex UI in React while keeping our state updates safe and predictable. We'll explore tools like Immer, React portals, toast notifications, and error boundaries, all focused on writing more cleaner and reliable React code. When our state becomes deeply nested, simple updates become complicated. Instead of changing one value, we have to copy multiple layers like arrays and objects. This makes the code longer and increases the chances of making mistakes. To update nested data manually, we usually create a new array, then a new object, and then replace it back into state. This works, but the process is very verbose and hard to maintain, especially in real-world applications. This is where Immer helps. Immer lets us write code that looks like we are directly modifying state, but behind the scenes, it keeps everything immutable. So we get a simpler code without breaking React's rules. So how does Immer work? We wrap our logic inside a produce function. Immer gives us a draft version of state and we can change it directly. Once we are done, Immer automatically creates the new immutable state for us. Instead of useState, we can use the useImmer hook. It gives us the current state and an updater function. The difference is that the updater receives a draft object, so updating nested values becomes much easier. In this example, we have a user profile with nested data like address. Using useImmer, we can update fields like name, email, street, or city with simple assignments instead of complicated spread syntax. Sometimes UI elements like modals get stuck because of parent CSS styles. Even if we use position fixed, certain properties like transform can trap them. This is where React portals come in. With portals, we create a separate target in our HTML, like modal root. Then we use create portal to render the component into that location. The component stays logically in the same place in React, but visually it moves outside. Toasts are a perfect example of portals. We render the notification into a toast root so it floats above the app. This prevents layout issues and keeps the UI clean. Even with good code, errors can happen. Without protection, one broken component can crash the whole app. Error boundaries act like safety nets that catch errors and show a fallback UI instead. Error boundaries are usually written as class components. They detect errors using lifecycle methods and display a fallback message while logging the issue for debugging. To summarize, Immer makes state updates easier, portals help UI escape layout problems, toasts use portals for floating feedback, and error boundaries keep your app stable even when something fails. These patterns help you build stronger and more maintainable React applications. Now let's look at the problem over here. In React, we always update state immutably. That means we never change the existing state directly. Instead, we create a new version of it. This is simple when we are updating something like a number or a string. But when our state contains deeply nested objects or arrays, things quickly get complicated. In our example here, we are building a calendar app that stores events. Each event has metadata, and inside that metadata, there's a list of invitees. Now imagine we want to remove a specific invitee, Gerarda, from the team meeting. To do that, we have to go through this path, from events to team meeting to metadata to invitees. Updating this immutably requires copying every level along the way. Let's see how that looks in code. Here, we are using React's useState to store our events. Now if we look at the function called handle remove manually, first we find the index of the team meeting event. Then, we create a new invitees array by filtering out Gerarda. After that, we create a new metadata object that includes the updated invitees. Next, we create a new event object. Finally, we create a new events array using map to replace the old event. As you can see, we are copying data at multiple levels just to remove one item. This works correctly, but it's long, hard to read and easy to break if we make a mistake. This is exactly the problem Immer is designed to solve. Immer lets us write code as if we are directly modifying state. But behind the scenes, it safely creates a new immutable copy. It does this using something called a draft state. Now let's look at handle remove with Immer. We wrap our update logic inside produce. Immer gives us a draft version of our events. Inside the draft, we simply find the event, find the invitee and remove it using splice, just like normal JavaScript. That's it. No spreading objects, no copying arrays manually. Immer handles everything behind the scenes and gives React a new immutable state. The logic is much clearer. We're focusing on what we want to do, not how to copy the data. Now when we click remove Gerarda manually, it uses the long method. And when we click on remove Gerarda using Immer, it uses the simple method. The reset state on the other hand restores the original data. Both removal buttons produce the same result, but the Immer version is much easier to understand. Now that you've seen how Immer makes nested state updates much simpler using the produce function, let's take the next step. In real React applications, instead of manually calling produce every time, we often use a hook called useImmer. You can think of it just like useState. It gives us state and an updater function, but with Immer built in. The big advantage is that inside the updater, we can directly modify a draft version of the state, and Immer automatically handles creating the new immutable state behind the scenes. To practice this, we are going to work on a simple profile editor. The user data includes nested fields like address, so it's a perfect example to see how useImmer simplifies updates. Your goal will be to replace useState with useImmer and implement the logic so that when you type into the inputs, the profile updates correctly using draft mutations. Try to work on this task yourself. Now let's talk about a common UI problem. Imagine you're building a modal, a pop-up that should appear above everything else on the screen. Usually we use CSS like position fixed to make it float. But sometimes a parent component somewhere in the app has styles like transform, filter or certain stacking contexts. When that happens, the model can get trapped inside the parent. It may appear cut off, positioned incorrectly, or hidden behind other elements. This makes the models fragile because their behavior depends on CSS far up the component tree. So how do we make sure our model always renders cleanly above everything? This is where React portals come in. Portals let us render a component's HTML into a different place in the DOM, outside the main application root. You can think of it like teleportation. We still write the model inside our component in React code, but when it renders in the browser, it gets placed somewhere else, like a special container called modal root. Now coming to index.html. In this HTML file over here, we have two containers. One is the main root where the React app renders, and another is modal root, which is specifically for portal content like modals. This gives React a safe space to render floating UI elements. Now let's look at the main app component. We use useState to track whether the modal is open. When we click the Open Modal button, we set the state to true, which renders the modal component. When we close it, we set the state back to false. Now you may notice this part. We only render the modal when isModalOpen is true. This is standard React conditional rendering. Now let's look inside the modal component. First, we get a reference to modal root from the DOM. Then, we define the modal structure, including a backdrop, dialog, header, and content. The backdrop listens for clicks to close the modal, while clicks inside the dialog are prevented from bubbling. The key line is where we call createPortal. CreatePortal takes two arguments. First, the JSX where we want to render. Second, the DOM node where it should appear. React then renders this modal inside modal root instead of inside the normal component tree. Now if you inspect this page, you will see that even though the modal component is written inside app, its HTML appears outside the main root. Because of this, it's no longer affected by parent CSS, and it can safely float above the entire UI. Now when you click on Open Modal, the pop-up appears above everything. You can click outside to close it, or we can use the close button. Portals make UI components like modals, tooltips, dropdowns, and notifications much more reliable. They prevent layout bugs caused by stacking contexts and keep your component logic clean while giving you full control over rendering. So the key idea is simple. React portals let you keep your code organized while rendering UI exactly where it needs to be in the DOM. Think of portals as a way to write components in one place but render them somewhere safer. Now that we've seen how portals helps us render modals outside the main app, let's apply the same idea to another common UI pattern, toast notifications. Toasts also need to float above the interface and shouldn't be affected by layout or parent styles. In this task, we'll modify a toast component to render into a toast root using create portal, just like we did with the modal. Focus on identifying the portal target, wrapping the JSX, and styling it so it appears in the corner. So that's a wrap up on how to manage states safely and build complex user interfaces. To really understand this concept, make sure to head over to the CodeChef platform and try out the practice problems yourself. That's where the real learning happens. So that was it for this lesson, and I'll see you in the next one. Thank you.